All right, we are going to go over graphing sine and cosine with transformations, and we're going to do just both transformations today. I know section 224 is technically just vertical and horizontal shifts, and then 225 is horizontal and vertical stretches, but we're going to just kind of do all of graphing today. So, before we start with the transformations, I just want to point out that you do need to memorize the graphs of sine and cosine and be able to graph those quickly. So when you're graphing them, just think about the unit circle. So if you're thinking, oh, I need a pen to work. All right, so on the unit circle, as you go around, starting at 0 radians all the way around to 2 pi, that is one full cycle. So with the quote-unquote 5-point method, what that means is that you're going to have 5 points starting at 0 and ending at 2 pi. So I'm going to go ahead and mark. So this is 0. This is going to be pi over 2. This is going to be pi. This is 2 pi. So see how this is like 5 locations, including 0, 0, half pi, pi, 3/2 pi, 2 pi. That's 5 x coordinates. And those are going to be like where my 5 points are. And that's going to complete one full cycle. If you think about the unit circle with sine, at 0 radians, sine is the y coordinate, right? So the y coordinate starts at 0, then it has a y coordinate of 1, a y coordinate of 0, a y coordinate of -1, and then back to 0 again. So I'm going to let this equal 1. So sine starts at 0, 1, 0, -1, at 3 pi over 2, and then back at 0. So this is just something you need to memorize. Sine starts at 0, goes up, passes through 0 at pi, goes down, and then back up. Okay. Now that's only one cycle of pi. One cycle of sine. That's one period. Okay. So the notation we use is lowercase alpha. So that's one period. That doesn't mean that's all of sine, right? Sine goes on forever and ever. So I'm just going to kind of continue my pattern here. Negative, positive, and forever and ever. This would be -2 pi right here. All right, so that's sine. Then we have cosine. So again, thinking about the unit circle, one full cycle is going to start at 0 and end at 2 pi. I'll go ahead and mark -2 pi here. Now cosine is the x coordinate, right? So on the unit circle, the x coordinate starts at 1. Then the x coordinate is 0, x coordinate of -1, x coordinate of 0, all the way back to 1. So with cosine, we start at an x coordinate of 1. I'm sorry, an x coordinate on the unit circle. I know it's confusing because I'm talking about the unit circle. Cosine is the x coordinate, but on this graph, the input is radians. So anyway, cosine value starts at 1, then a cosine value of 0, cosine value of -1 at pi, cosine value of 0 at 3 pi over 2, and then 1 at 2 pi. So those are my 5 points, 5-point method. 1, 2, 3, 4, 5. And it's cyclical, so it just repeats over and over and over again. So memorize those. All right, so now we are going to do some transformations. So the kind of the general form of the equation is y equals plus or minus a sine of 2 pi over b x minus h plus k. And that's kind of the general form of the equation. Don't ask me why I left myself so little space to write that. Now, plus or minus indicates the vertical reflection, if there is one. A is the amplitude. 2 pi over b gives you the period. Oh, I'm sorry. That shouldn't be 2 pi over b. Okay, I could edit this video. I'm not going to. Just erase the 2 pi over b part. The 2 pi over b is the period. We'll get there in a second. I was jumping ahead. So it's just b times x minus h plus k. Go ahead and erase that. Fix that mistake. Sorry about that. We'll get to the 2 pi over b part soon. But the b part is going to give you a horizontal stretch or reflection. The h is a horizontal shift, and the k is a vertical shift. So it works just like a parabola or an absolute value, where you have your vertical stretch is being multiplied on the outside, your vertical shift is going to be added or subtracted, your horizontal stretch is multiplied inside, your horizontal shift is added or subtracted inside. And just make sure that that b value is factored out. Okay, so just like any other transformation, it's just, or with any other function, it's just trig this time. Okay, so in this first example, our amplitude is our vertical stretch, which is 2. Okay, the period, so you'll notice that this is just 1x. So our b value is just 1 here. I'm not multiplying by anything, so b value is 1. So the period is 2 pi over b, which in this case is just 2 pi divided by 1, which is 2 pi. So if you just think about a regular sine or cosine graph, as we did before, one cycle is 2 pi. Period is 2 pi. So in this case, because there is no horizontal stretch or reflection, the period is still 2 pi. So this is the equation you're going to use to find the period. It's 2 pi divided by this b value. That's why I'd written 2 pi over b before, but the b value goes inside the function, and then 2 pi over b is the length of the cycle, the period. All right, phase shift. So that's your horizontal shift. So as you can see, we have x minus pi over 4. So think about what that means if this is like a parabola or an absolute value or a square root. What does it mean if you have x minus a value? So this is going to be a shift to the right pi over 4 units. It's a shift to the right because it's x minus h. And then your midline is your shift up or down. So that's going to be -1, and that's y equals -1. So that's going to be your shift up or down. All right, so you always want to start out by finding these 4 things: amplitude, period, phase shift, midline. And again, amplitude is just the vertical stretch. The period ends up being the horizontal stretch. Phase shift ends up being the horizontal shift. Midline is the vertical shift. Okay, now your first point, again, we're doing the 5-point method. Your first point is going to be where your phase shift is. So our first point is going to be at x equals pi over 4. And these are just x coordinates. We'll do the y coordinates here in a little bit, but I just want to point out the x coordinate. Right here, I'll even write x equals pi over 4. Your first point is always going to be starting at your phase shift. Now, because we're moving this whole graph over, so if you think about our original sine graph, if you were to move the whole graph over pi over 4, that means the first point is going to change. The third point is going to change. The fifth point is going to change. The second point is going to change. The fourth point is going to change. All of the points are going to shift over pi over 4. So to find where the cycle ends, do your phase shift plus the period. And that's going to be where the cycle ends. So the beginning is, instead of starting at 0 radians, it's going to start at pi over 4, because that's our horizontal shift. Our last point is going to be our horizontal shift plus the period. That's going to be where our last point is, where our cycle ends. So 2 pi is the same thing as 8 pi over 4, right? Get a common denominator, so that's 9 pi over 4. And then our third point, so I always do first, fifth, and third. Just think about like midpoints, right? If I have the first point and the fifth point, then the third point is going to be the midpoint. So 1/4 plus 9/4 is 10/4. Divided by 2 is 5/4. All right. So on my graph, I want to decide how I'm going to scale. If I do fourths, let me just try this out. That would be 1/4, 3/4, 5/4, 7/4, 9. Okay, so I don't have quite enough room to do 9/4. So I'm actually just going to do, I'm going to scale by pi over 2s. So that's going to be pi. This is going to be 2 pi. So I'm gonna have to go in between, but that's okay, it's not a big deal. Negative pi, et cetera, et cetera. So I have to figure out my scaling. All right, my midline is at -1. So your midline is gonna be kind of your fake x-axis. The reason I'm calling it your fake x-axis is you'll notice that in our original graph, we crossed the x-axis. In sine, we crossed 3 times. Those were 3 of our 5 points using the 5-point method. But when we shift up or down, now we are going to be crossing the midline at those points. So I call it my fake x-axis. And my amplitude is 2, so that means instead of going up and down 1, I'm going to be going up and down 2. So I'm going to start with my first point. It's at pi over 4. So that is going to be here. Based on my scaling, if this is 1, I'm at 1/4. So I'm going to start at 1/4. And sine, remember you need to memorize this, sine starts on the x-axis normally. Sine starts on the x-axis, goes up, down, has a minimum, and then back to the x-axis. Again, think about the unit circle. On the unit circle at 0 radians, sine has a value of 0. Then at pi over 2 it has a value of 1, et cetera, et cetera. So instead of starting at 0 radians, we're going to start at pi over 4. And instead of starting on the x-axis, we're going to start on our midline. So again, we're starting at the midline because normally sine starts at the x-axis. The midline is our fake x-axis. All right. Now our fifth, I'm going to go ahead and jump to our 5th point. Our 5th point is where the cycle is going to end. That's going to be 9 pi over 4. So 9 pi over 4 is 2 1/4. So that's going to be where it ends. And sine ends at the same value in which it started. So if we start at -1, then we're going to be ending at -1. Our 3rd point is 5/4. So that's just the midline, the middle. I'm sorry, not the midline, the midpoint, the middle of 1/4 pi and 9/4 pi. So see how these all 3 are equidistant? It's because it's the midpoint. And again, the reason I'm on my fake x-axis here is because that's what sine does. And I have this memorized, that sine starts on the x-axis, crosses the x-axis, ends on the x-axis at points 1, 3, and 5. So I'm doing the same thing here, but I just have these shifts, and I'm starting at the midline. Okay, and then sine has a maximum in between your first 2 x-axis values. Now, normally sine has a maximum of 1, but because of our amplitude, we have a maximum of 2. So from the midpoint, I'm going to go up 2 units. From the midpoint, I'm going up 2 units. Now, I'm not worried about where I cross the x-axis. I'm worried about where I cross the quote-unquote fake x-axis. So the points that I want to see are where you cross the midline. Those need to be specific. Points 1, 3, and 5, where I cross the midline, and then my maximum is specific. It's going to be at 3 pi over 4. And then my minimum will be at 7 pi over 4. Oops. Going down 2 because my amplitude is 2. So again, remember the amplitude is the distance from the midline. So again, I have a horizontal shift of pi over 4 that shifts all 5 points over pi over 4. So the way that I do it is I figure out my beginning point, my end point, and then from there it's midpoints. Between 1 and 9 is 5, so 5 pi over 4. Between 1 and 5 pi over 4 is 3 pi over 4. Between 5 pi over 4 and 9 pi over 4 is 7 pi over 4. So those give me my 5 points. Those are my 5 specific points. And then from there you can just repeat the pattern. Et cetera, et cetera. So I'm just gonna. Now the standard we're gonna use is always graph 2 cycles, at least 2 cycles. That's what I want your standard to be. I want you to always graph at least 2 cycles. Okay. All right, now for our next example, we have a cosine graph. So our amplitude is 3. Now it's not -3. The negative is going to be a reflection. We'll deal with that later. But the amplitude is the distance from a midline. So amplitude is always positive. So our distance from the midline will be 3. The period is 2 pi over b, which in this case is 2 pi over 1/3, which is 6 pi. So it's going to take 6 pi to complete 1 full cycle. The phase shift, so we're not adding or subtracting anything here, so there is no phase shift. And then the midline is the vertical shift. That's going to be y equals +1 in this case. So my midline, go ahead and switch colors here. It's going to be +1. From there, I'm going to be going up 3 and down 3 for my maxes and mins. My phase shift is 0, so I don't have to worry about like shifting the points over. I'm going to be starting at 0 radians. But I'm ending at 6 pi, so I need to have 5 points across 6 pi. So it's not going to be perfect. So I'm just going to scale, let's see. Yeah, I'll just scale by pi. So this will be 2 pi, 4 pi, and 6 pi. So I'll complete 1 full cycle by 6 pi. Now I want to point out that I'm saying 5 points. You're really splitting these 5 points into 4 quadrants. Right? On the unit circle, I have 0.1, 0.2, 0.3, 0.4, and then 0.5 just returns to where I am. So if I have 5 points, I'm really splitting my graph into 4 sections. If that doesn't help you, don't worry about it. It helps me personally to figure out that like, oh, okay, I'm gonna have 5 points, but that's split into fourths. Anyway, so my first point is going to be at x. There's no phase shift, so my first point is just x equals 0. My last point would be 0 plus 6 pi, so that's going to be 6 pi. So this one's easy. I'm going to be beginning at 0 radians and ending at 6 pi. And then my midpoint will be at 3 pi. Between 0 and 6 is 3 pi. So this one's going to be really easy to find my 5 points because I don't have any fractions to deal with. Although when you have fractions, it shouldn't be that difficult to deal with. Anyway, you're honors pre-calc students. Okay, so this is a negative cosine graph. So think about a regular cosine. Again, you need to memorize this. Cosine starts at a maximum, crosses the x-axis, minimum, crosses the x-axis, and ends at your maximum again. Max, x-axis, min, x-axis, maximum. That's what cosine does over 1 full cycle. Now this is a negative cosine. So think about the reflection of that. The reflection of that would start at a minimum, cross the x-axis, have a maximum, cross the x-axis, and have a minimum again. Okay, so I want you to use that reflection Sorry, I was just trying to erase all of this. Think about that reflection as you're graphing. So we are going to start at a minimum. Negative cosine means start at a minimum. So from the midline, I would be going down 3 units. 1, 2, 3. I have no phase shift, so I'm starting at 0. I'm starting at an x value of 0. My amplitude is 3, so I'm 3 units away from my midline. And I'm starting at -3 from the midline because this is a negative cosine. Instead of starting at a maximum, I'm going to be starting at a minimum. Regular cosine start at a maximum. So I'm going to start at a minimum. I'm also going to be ending at a minimum. And my maximum will occur exactly between my minimums. So everything is always equidistant for your cycles. Okay? A minimum is always between two maximums. A maximum is always between two minimums. So if I have minimums at 0 and 6 pi, then at 3 pi, I will have a maximum. Again, 3 units away from the midline. And then that's 3 of my points. For points 2 and 4, just do midpoints, okay? Between 1 and 3 is, between 0 and 3 is 1.5. So that's gonna be here. It's where it crosses the fake x-axis, crosses the midline. Between 3 and 6 is 4.5. That's where it's gonna cross the midline. All 5 points should be equidistant in terms of your x values. So just do midpoints. Start with your first point and your last point, and then do midpoint, and then your other 2 midpoints. Okay? And then, once you have that, oops. So I'm just adding my 2 cycles. You have 2 cycles. Why aren't you erasing? Okay. So again, your maximums should be 3 units away from your midline. Your minimums should be 3 units away from your midline. We are starting at -3 because normally cosine starts at a maximum, but this is a negative cosine, so we start at a minimum. So that's 1 cycle. And then here is a second cycle. All right, so I know that was a lot of information. Your first few problems that you're going to be doing, you don't be freaked out if you can't do all of this at once, because it's going to kind of ease you into it. You're only going to do like 1 transformation at a time, and then we'll start combining transformations. I just wanted to make sure that in the examples I give you in this video that I cover everything I need to cover. So I covered amplitudes, period change, phase shifts, midline, reflections, all of that good stuff. But you really need to start by memorizing sine and cosine. Again, sine starts at 0, max, 0, min, 0. Cosine starts at a maximum, 0, minimum, 0, maximum. Once you have those memorized, it's a lot easier to make these transformations. But it really just takes time and practice. So that's what you're going to work on now, is practicing by doing the rest of this worksheet. Good luck.